Okay, welcome to the session, everyone. Thanks for joining us. My name is Mark Dempsey. I work for Carolina Farm Stewardship Association.
I'm Pat Battle. I'm Director of Living Web Farms.
And we're happy for you to join us today. We're going to be talking about the role of sunshine in improving soil fertility via the soil microbial food web. And doing our best to maximize the cover of soil by plants and the important role that we think that plays in soil fertility and crop management. So let's just go ahead and jump right on in. So for a little bit of background, we think that plants are excellent regulators of the environment in which they live, of this soil environment. So they use the resources that they have at hand, which is really only sunshine, water, air, and some nutrients, to form these partnerships with soil microbiology. And in turn, those partnerships can improve nutrient access for plants, among a lot of other things that we'll talk about in just a moment. And so in this sense, solar energy capture by plants is this kind of unique bottleneck to the way plants function in this sort of hot and humid southeast, where they aren't really limited by the amount of water. We're not trying to grow plants in a desert here in the humid southeast, and we're not trying to grow in a tundra. And so in a way, this sunshine is the thing that kind of limits the biological activity that plants enable underground through those partnerships, and to a large degree, some of the nutrients that they have access to.
And I think, Mark, you gave me just today, because you researched it for this talk, the easiest way to maybe get people to get the point we're trying to make. You researched the efficiency of the use of sunlight by plants. And it surprised you and surprised me. They're only about 5% efficient, right? So if you only have your crops out there, you're only getting 5% of this incredible wealth called solar energy. If you have other plants around them, they are also each getting 5%. And they're all pumping that energy into the soil. So the fact that they're inefficient unto themselves, supposedly, that's actually our judgment, but the fact that they only get 5% that we can measure efficiency from that sunlight is greatly remediated by the fact that there can be tons of plants. And that's what you see in nature. You see every bit of solar capture possible in most natural landscapes. And that's the point we're trying to make here.
Yeah. So given that efficiency is quote unquote low, it's on us, the managers of our farms or fields or whatever, to do our best to try to maximize space, because efficiency is a little bit low. So that's a good way to think of it. So to talk a little bit about cooperation between plants and soil microbes, I think it's important to think about this all the way through. So the plants select the soil microbes that they partner with basically from the moment that they germinate, which I think is super fascinating. So as they're germinating, they're selecting the bacteria and the fungi and other critters underground that they're choosing to be their partners. And plants don't just kind of, take from their friends in this instance. They actually invest significant resources in these partnerships that are microbes living in their roots, around the roots, and in the soil just beyond that. And it's noteworthy that the majority of carbon fixed by plants, that's through the process of photosynthesis, powered by sunshine, about half of that carbon makes its way underground. So plants are kind of pumping a lot of it. It's actually more than half, but the majority is going underground, and about half of that is actually released to soil microbes to feed those microbes or to communicate with them. There's definitely two very distinct channels going on there. But the idea is that they're fostering this environment that is beneficial mutually to the plant and to the microbe, and they talk to each other a lot so that they know what each other wants or needs in that sense. So in return, soil microbe partners help provide water to plants, they help provide nutrients to plants, and also protection from pathogens. It's a fascinating microscopic world under there if you're not already familiar with it. So just for a very brief rundown of some of the relationships that exist between plants and their microbial partners. At the top of the list that you may or may not have heard of, this is a pretty well-known one, is mycorrhizal fungi. So it's fungi that partner with plants via their roots. And you can see some photos here. The photo on the top right is a pine seedling germinating that's intended to just show the extent of this quote unquote hyphal network. That's like the fungus version of a root, essentially. The hyphal network that extends out from beyond the roots. And I can't account for the veracity of this photo. I feel like this photo is everywhere over the web. It could be a Photoshop thing, but it illustrates a point, right? This is like a very extensive hyphal network that's extending from a root system. The photograph on the bottom right shows fungal hyphae reaching from a fine root of a plant, and fine root means like the teeniest, tiniest of roots, which you can see that in the picture, it's a pretty fat root. And the little thread-like structures that are coming off of that are reaching over to a soil particle, and they're teeny tiny. And that's important to note because one of the roles of mycorrhizal fungi is to vastly increase surface area. And so by having these teeny tiny thread-like structures that network throughout the soil, have a much higher surface area than even the finest of fine roots of plants do, they enable plants to access more nutrients and water and so on that they otherwise wouldn't have access to. And so that fungal hyphae that branches between the root and the soil particle is literally fungal hyphae checking out the soil particles, looking for water, looking for nutrients. And fungal hyphae have a unique ability to mine soil minerals that most plants do not have the ability to, or they have just extra abilities to do that. And simply because of the added surface area that they have, they vastly improve access to water and to a large extent to nutrients.
And Mark, the point about minerals, I think, is one that we all want to really reflect on. It is a major motivation for maximizing your plant populations rather than going for bare spacing of soil, because industrial ag and much of our food system is looking at a phosphorus abyss. We, as a world agricultural community based on industrial ag, are going to run out of phosphorus, probably before we run out of oil. It's a major issue. It's an issue for geopolitical disturbances, etc. That issue is incredibly less severe if you are harnessing the power of mycorrhizae. Mycorrhizae have the ability, the vascular arbuscular mycorrhizae have the ability to exude acids that make apatite, the raw phosphorus in the soil, which is still a lot of it there, available to plants. It's just that we've become dependent on this, chemical fertilizer, which actually, when you apply it, suppresses the mycorrhizae's motivation for making this available. And yes, most plants that we grow, with the exception of brassicas and chenopodiums, the beet family, have this ability. So if you have more plants growing more mycorrhizae, you are accessing more phosphorus and are less susceptible to that particular aspect of fragility in the current food system.
Agreed. Yeah, that's a great point. And while I know this talk is focused on soil nutrient kind of access or management, it's worth re-emphasizing that mycorrhizal fungi, that partnership, is also important for plants. For water. And so that the photo on the bottom right is actually two, I think, cotton plants, one grown with and one grown without mycorrhizal associations under drought conditions. And I think it's pretty clear which one had the mycorrhizal associations, the one that has just overall better growth on the right, enabled only by the fact that it had the association with mycorrhizae and ability to get more water. So moving on, nitrogen-fixing bacteria is another really important one that you should be thinking about in your crop management, and definitely from a nutrient management perspective. And so I'm going to guess that most people are familiar with this relationship between plants and certain bacteria in soil, and it's most well known through legumes. And so the two pictures on the bottom are nodules of different legumes that contain bacteria that fix nitrogen from the atmosphere as if it were free, although it comes at an energetic cost to the plant provided through sunshine. And we know legumes to be the big nitrogen fixers, but it's important to note, or at least consider, that legumes are not the only nitrogen fixing plants in quotes, because it's actually the microbes that are doing the work. But there's a good bit of other nitrogen fixation that can happen across a lot of different kinds of plants, that maybe spans I don't know, somewhere between 5 and 10 types of bacteria, at least that we know of. And so the example on the top right is sugarcane. Sugarcane is probably the best known example of a non-legume nitrogen fixation situation. The name of that bacterium is given just below the sugarcane line there. And it actually hosts that bacteria between its cells within the stem, maybe within the roots, but definitely like within just like the above ground plant itself, which is thought to be why sugarcane stands remain productive over a few years without adding nitrogen, just because they're actually able to get this stuff from the air without having to pull as much from the soil. And it just so happens that that bacterial species and a handful of other ones have been noted in other crop species that range across a bunch of different kinds of crops. And I think we don't know enough about it to say like you should plant this to get added nitrogen to the situation, but that maybe the take home is that there is a benefit to plant diversity that enables you to take advantage of nitrogen fixation.
And there's some pretty astounding examples of this. One that I love to share. When I learned it, I just got to marvel in the wonder of nature yet again. Zev Friedman shared with me that there's an indigenous corn that actually sends out adventitious roots up its stalk, and on those roots there are nitrogen fixing bacteria. So it is accessing nitrogen for the corn from the atmosphere. And that, of course, is what the whole point is. Our atmosphere is largely nitrogen, and plants have to access that, and they count on the life for that. So the more we create the diversity, the more forms of life that are there, the better chance that plants will have their moment to capture nitrogen.
Yeah, and that's a fun and weird example. Look that one up. The pictures of the goop growing on the adventitious roots is pretty neat. Okay, so moving on. I guess one other kind of broad category of partnership between plants and microbes is just so-called plant growth promotion. And there's it's a huge umbrella category, sort of on purpose, that provides a variety of maybe quote unquote services to plants, including things like pathogen protection. So if you have pathogens that are trying to find their way into plant roots, for example, there's quite a few bacteria species that are able to improve the resistance to that. And the same is true for other things like stress tolerance. There are certain bacteria that can help a plant basically physiologically take on more stress, whether that's like water stress, nutrient stress, et cetera, other biological stresses or abiotic stresses, excuse me. And then, of course, nutrient acquisition through pathways that we haven't actually talked about that are not mycorrhizal or nitrogen fixing. And if you're able to, you can pause this and look up any of the references that are shown here. There's some pretty neat research that's been done on this. A lot of cool work and a lot of cool relationships. However, it is my opinion that despite knowing a lot of really cool things about soil microbes, that we probably know far less, or there's probably far more unknown relationships than ones that we actually do know about. That's kind of
very likely
my gut take on that. We can learn about them in time. It's just where we're at. We're sort of at this cutting edge, and this is where we are now.
But a point I love to make, I've made in giving beneficial insect talks, where people want to know every last thing. It's like, I don't know every last thing for sure about either soil biology or beneficial insects. But what's important is I create the conditions for the life, because the life does know it. We don't have to know it, the plants know it. As long as we make sure they're there and they have the opportunity, they're going to be doing it whether we know it or not.
Yep, absolutely. Okay, so shifting gears back to the original kind of idea here. So what we're trying to do with as plant managers is to maximize the capture of sunlight with plants. So that's like across growing spaces. So maximizing it across your fields, across your garden area, whatever it is, and over time throughout the season. So taking advantage of any bare ground that you might have at any point in time. And we think of this as a way to effectively like widen that bottleneck of sunlight being pumped underground to communicate with microbes, enabling more access to soil nutrients. Excuse me.
Basically, the more bare ground you have, the tighter the bottleneck.
Yes, yes, absolutely. And so, in a way, you can think of bare ground as just a lost opportunity. It's one that weeds will surely fill in, of course. But if you happen to love weeding and leaving that ground bare between your plants, then that is a real lost opportunity. And so, throughout this talk, we're going to advocate for ways that you can kind of plug in. Try to minimize the bare ground thing without sacrificing too much yield, and maybe provide a lot of other services to your plants, to beneficial insects, so on and so forth.
Basically, there's a brilliant and dynamically interactive living architecture of plants that occurs in nature, and we can best capture that when we're doing cover crops by doing multi-species cover crops. We can best capture that when we're growing plants. We're growing crops by including cover crops in the areas that normally would be bare, and all of those plants are delivering energy to the soil through soil exudates. And so the more diversity of plants, the more diversity of architecture, the more sunlight being captured. If you just look at a multi-species cover crop in a field, you'll just notice that, how there's just virtually no light that makes it to the ground, which is exactly what you want. And meanwhile, these plants are also, of course, protecting the ground from hard pounding rains and baking sun. And so maximizing that incredibly brilliant dynamic interaction of all these soil types and leaf types, or rather leaf types, can really enhance your fertility.
Mm-hmm. Okay, so in order to make this happen, I think that you can kind of break this into three just sort of general categories. So you can work cover crops into your rotation or into your management by overseeding or interseeding cover crops into a growing crop. The idea being that you're trying to like minimize the time frame in which you like get one crop out of the ground and you're establishing a cover crop. You kind of try to make that happen at the same time in the same place. And there might be an opportunity for some cover crops to double as a cash crop. Category two would be to basically be planting different cash crops in the same space in the same time, for which there's like many options and methods to get there. And then finally, to maybe use weeds when all else fails, or when it pays to use weeds, depending on the weed, of course, because things can get hairy and out of control very quickly. But don't always think about weeds as an inherent problem, and maybe they can be a patch over the ground when you don't have the time to deal with a weed problem, so long as you don't let them go to seed, of course. And some weeds are plenty nutritious, can fetch a little price at the market, and certainly should be thought of in the kitchen garden as good guys a lot of time.
Actually, Mark, I would say probably most of the weeds that you find in your garden that are performing this function we're describing are actually more nutritious than your crops by a significant factor. Some of the deepest nutrition you have is those weeds.
Absolutely. Yep. Absolutely. And we'll cover a couple of examples of those. Okay. And so then finally, for like the kind of guiding concept of the maximizing solar fertility idea is to find complementarity in the crops, cash crops or cover crops that you're growing. So ones that have complementary, let's say, growth habit or architecture, so that you've got like a broadleaf crop that's low to the ground and it's sitting underneath a taller, finer leafed crop where like sunlight can still get through to it. And the height difference and the difference in the leaf shape allows that to happen. And similarly, there might be complementarity or just like a complementary preference for sun versus shade. We'll show an example of that. And then definitely, and I think maybe this is where most of the action is happening, is the transition from warm to cool season or vice versa, when you can kind of relay crops, cash crops together. And then just taking advantage of the timing at which you seed or transplant or whatever it is to get things in the ground to ensure that the one that you want to live a competitive advantage over the other and does better, gets close to the yield that you want, but still you have this other crop going on that you can also manage in a way to meet or suit your end.
And I'd say that the other piece that you can play with here is the growth rate of some plants. So you can put something like purslane in, sow purslane after your corn is maybe a foot tall or something. There'll be no competition at all, and yet it is going to grow fast enough that it's going to be able to capture enough sunlight that it's going to be well established by the time it starts to get canopied by the corn. And you could get several harvests from that purslane prior to the corn actually getting to a point where there's not much else going to be growing. And a wonderful book that's out of print, but you can find it, and I think it might be one of those ones that Google has in its vast collection. It's called Weeds, Guardians of the Soil. And it actually literally uses the purslane example. That seeing that happen in a field that as a young person, he weeded for a farmer, and the farmer came out at lunchtime and said, leave the purslane in, it's good for the corn. Came back that summer, late in the summer after a severe drought, and the half of the field that he had weeded the purslane out was shriveled up, and the half that had the purslane still in there, now gone to seed, was actually green and thriving. So it's a great example of what we're talking about.
Mm-hmm. Yeah, and it's a delicious one to eat too.
Okay, this is actually, I first experienced this serendipitously. We had planted, I think, beets into a bed, and there was a bunch of volunteer buckwheat that came up. And the buckwheat would have eventually been a problem and competed with the beets, but we had an ace up our sleeve, and that was, you see the row cover there on the right of the slides. That row cover was placed there because this was growing basically in probably mid-November. It was in a greenhouse, but that greenhouse wasn't heated and was still going to freeze. And so we could allow the buckwheat to keep growing, suppressing the normal winter weeds, which we would have had plenty of, like chickweed and henbit. If you ever tried to weed those out of a beet crop or something, it's a lot of work, right? But they don't grow as fast as the buckwheat. The buckwheat had enough warmth because it was in a greenhouse, was smothering those. The crop, which was Elegance grazing mix, was doing fine with the buckwheat, but was going to be disadvantaged pretty soon. We got to choose on a cold night in November when to terminate the buckwheat. We pulled the cover crop over the buckwheat and the Elegance mix for all the nights that we wanted the buckwheat to be there. And then when we finally said, well, the buckwheat's getting too rambunctious, we left the cover crop off. The buckwheat all froze and the Elegance mix was released. And actually just now I was thinking, that is a little bit dicey maybe for some people, because you could actually, not get it right. Or what if you didn't get a frost? What if we had a year like 2011 where it never really got very cold at all and the buckwheat, it wouldn't die in the greenhouse? Then you might have a problem with it. So you might substitute instead broadleaf cress, which is going to grow equally fast, and you could harvest it to control it. But what you want is something else in your mix that's growing really fast, faster than those weeds. And so that's the concept here. And we a couple times have successfully used the fact that we would get a frost to use buckwheat for this, and it's worked pretty well. And it's just an idea. I wouldn't say that we've got this figured out, and I guarantee you that it'll be a while before anybody's certain of how that's going to work, but it's a possibility. Okay, and this was an example of me using a system which was developed the year before, which we'll see a slide of later on, which is that we're constantly trying to control weeds, and we're busy, and we have access where we are to leaves. We get leaves delivered to us by neighbors. I love that one neighbor who used to burn leaves all through the fall and fill our neighborhood with smoke found out that he could deliver to us instead. And so he brings us, yards and yards of leaves. He has a little lawnmower with a cart on the back, and he brings us those leaves. So we mulch a lot, and we mulch this crop of cauliflower. But I'd learned about a year or two before that you can actually sow cover crop seeds on top of the leaves, because we would tend not to do this kind of cover crop planting because we wouldn't want to take the time to pull the leaves off again. But I thought about it, and as long as you have moisture, which we have plenty of here in Mills River, or you can apply moisture, those cover crops are going to be germinating on top of that mulch, and they can grow down through the mulch. And they do indeed, and they thrive. And so I took what I learned from that, and we'll talk more about that a little later, and applied it to planting pea shoots. Pea shoots are one of my ideal intercrops because you get paid to do it. It's like buckwheat. Yeah, sure, it can exclude weeds, but you have to work to get rid of it, and you're not getting paid to do that. With the pea shoots, I actually got 3 cuttings from these pea shoots. And they weren't really suppressing weeds at that point because the leaves are taking care of that. But what they were doing was pumping those exudates down, capturing that carbon, capturing the power of the sunlight and putting that carbon into the soil. And at the same time, giving me a cash crop. The one thing you want to know about that is you're going to rot that mulch away faster by having those leaves on top of that. For us, that's no problem. If you wanted that, let's say you're doing garlic, you might not want to do that in garlic because you might want that mulch to last you through the harvest. So garlic, we might have a different strategy. But for a brassica like this, cauliflower, which is going to be done by the first deep hard frost, then that's fine. You've just basically prepared your bed. And this slide is actually a favorite of mine because it was sent to me by John Rowland, who has our farm. He heard I was doing a no-till talk, and he described a situation where he decided to take advantage of solar energy to get himself another crop. He had planted largely radishes, forage radishes or oilseed radishes in this area. Radishes are great because they're accumulators. So in a lot of our fields, we have excess nitrogen and other nutrients left at the end of the season. You leave the soil bare, a lot of that's going to leach away. So we all know to plant cover crops. He planted radishes. Radishes almost always, if we have any kind of deep cold, are pretty damaged by late winter and aren't really going to go anywhere. They're going to kind of rot away. And he knew that was happening. He could see they were damaged. So he sowed spinach into them. And the spinach didn't do much for a while because of a lack of rain, but it was kind of nursed. Those little plants were nursed by these dying radishes. Then the rains came, the radishes, you can't even see them anymore. They disappeared, but in their disappearance, they released that accumulated nitrogen and other nutrients. And he got a bumper crop of spinach, hundreds of dollars worth of spinach, just for scattering spinach seeds into his radish crop. So that's a way that he took advantage of that solar energy while at the same time gathering a cash crop.
Yeah. And I think when you and I talked about this, we noted that in the picture, it's a little bit bare in places, and that maybe he could have plugged in your
That's where
peas,
the pea shoots would have been the perfect fit into
Yep.
there.
Yep.
They would have taken up that space. There wasn't a problem of weeds because the residue from the radishes, you can see, are kind of suppressing the weeds. But once again, the right day, and you're not going to plant pea shoots out there, when you've got a hot, dry week. You're going to pick a rainy week to put them out there because they're on top of the soil. You're not incorporating them. But it works. You can make it work pretty well. At least here in Western North Carolina, we have plenty of weeks where those pea shoots are going to germinate and get their roots down through that plant residue. And then this is an experiment I did the same time that I played with, for the first time, planting cover crops into a heavy mulch. And basically, we had a bed of beets. They've already taken some damage from cold. They're about 3 to 4 weeks out from harvest. And on the left, you can see right after the first harvest. We had another picture, but we can only fit so many slides in these kind of talks, that shows the beets densely planted really close together and just a few little green shoots popping up. That was the seed of the multi-species cover crop that I seeded into those beets 4 weeks before we harvested them, roughly. It could be 3.5, 4 weeks or something. Those cover crop seedlings were going to go nowhere as long as the beets were there. And you might wonder, I wondered, is it going to be worth doing this? Because what about the damage I'm going to do to those cover crop seedlings when we harvest the beets? And I figured I'd just try it. And you can see the result in the middle part of that slide, because that's what was left after we harvest the beets. And you can see at the very far end, there's still some beets that haven't been harvested. What I love is I actually wondered when I sowed this, did I sow enough? And I looked at this and thought I need to come back and put more seed on, but I didn't. And I love that I didn't, because the result was the final part of this slide on the right. And that's what happened from that one sowing of beets, where actually if we waited to harvest, we probably wouldn't have bothered to sow a cover crop because it wouldn't have been worth the expensive seeds for how long we'd be able to leave it in before we planted our tomatoes. But in this situation, we picked up 4 more weeks of cover crop time by sowing into the beets. And I'll let you cover it, Mark. This slide, we realize, is the moment to talk about how to make this cost effective, because we're talking about using a lot of seed here. And you all know, if you've been buying cover crop seed, it's not free. And so do you want to speak to density of planting?
Yeah, sure. I think it just raises the point of, especially when you're hand broadcasting, it's like really easy to be heavy-handed with broadcasting seed. And then you end up with like, one row or one bed that costs you $100 for cover crop seed. So in this case where you're interseeding, it's particularly important to go light on seeding, to like pay better attention to how much you're putting out, because maybe importantly, you're just trying to get a little bit of cover going while you still have a crop in there, and you don't want it to compete. And so to avoid competition, be more careful about that heavy-handed cover crop sowing thing. And it ends up fine usually, which is maybe itself in a lesson in like how not to go heavy-handed in broadcasting seed anyway. But it's more important in this case because you are at risk of putting your cash crop at a disadvantage by throwing out too much.
And I would say that this was definitely revelatory for me. I looked at that second middle part of the bed there and thought, I didn't sow heavy enough. I need to come back and sow. But because, frankly, I was fortunate to have too much going on and I didn't do it, I got the lesson of seeing what it produced. And it's helped me to actually back off on my seeding usually. I still get a little carried away sometimes. We all want success.
Was this going into winter, or was this coming?
This was coming out of winter.
Yeah. And so maybe to kind of like flip this around a little bit, it's worth just mentioning as like a general cover cropping practice. If this was going into winter, the closer you get to like plants shutting down for winter, you should be a little bit more heavy-handed with your cover crop sowing, because in warm weather, these cool season grasses and stuff that you're putting out, they tiller, they grow more shoots, and they can cover more ground. But the closer you get to things shutting down for winter, the less they're going to do that. And so it helps to have better coverage by just throwing out a little bit more. So just a word to the wise on that one. Okay, and then to kind of like flip this around a little bit, there's a chance that some small scale growers are experimenting with or using regularly a crop like wheat. But in case this helps to inform anybody who's growing at a larger scale, it's not a market gardener. Oversowing or frost seeding clover into wheat is like one of the best ways that you can work in a cover crop into this like relay cropping rotation. And if you're not familiar with frost seeding, it's when you go out like at late winter and you broadcast or you drill a cover crop, in this case red clover, into wheat. And the wheat, mind you, is only like 6 inches tall because it's dormant for winter. Excuse me. And if you're not drilling and you're just broadcasting, it's called frost seeding, because as the frost heave kind of makes the soil go up and down, it makes the seeds work their way into the soil over time. In this case, this is either a medium or a red clover. I'm sorry, a medium or a short red clover. And as the wheat is maturing, so like in this case, you can see the picture on the left, the wheat's drying down. There's no like, green left on that wheat. That's when the red clover begins to kind of like really get a foothold. And so then after that wheat is taken off, it's harvested in June, let's say, you have a well-established cover for the summer. It grows. If you were cutting hay or if you're grazing, there's like great opportunity there for that, at least one cutting. And then compared to going into fall, where if you were to like it could maybe compare to a bare fallow or whatever else, where you're like fall planting a cover crop to go into the next winter, your red clover is months ahead of that fall planted red clover, which gives you just like way extra season, way more biomass, way more good stuff just getting pumped underground during that time.
And I would actually add that that's a great example of a point I try to make to people. A lot, especially home gardeners, just tell me they don't have time to cover crop. And I use the example of tomatoes. You can come out, and once the tomatoes are a couple feet off the ground, you can come out and sow a cover crop. If you wait till August, you can sow a fall cover crop, but you could sow a summer cover crop and then just mow it down, sowing a fall cover crop into it. The truth is that as long as those tomatoes are in their big, still putting foliage kind of growth spurt on, that cover crop is going to look really anemic to you, and you're going to wonder why you wasted your seed. But tomatoes in particular, though it happens with all kinds of other plants too, they actually have a stage late in their season, which has a name for it, which I forget, where they start to lose a fair amount of leaves. And when that happens, that cover crop that was just kind of sitting there holding, wishing it had light, is completely released. And you can do that with a lot of crops. You put it in there on faith. And what the crop is going to do, it's not going to give up. Life is going to try to thrive. It's going to go, not a lot of sun, go deeper. It's going to be developing its root system, waiting for that moment. Because as we see in forest and everywhere else, that happens all the time in nature. Plants get started and then they wait for release. And the same, we can follow that same rhythm with this kind of cover cropping system.
Mm-hmm. Absolutely. Another throw out to anyone who might be working at larger scales in grain systems, et cetera, although this is still totally appropriate for folks at the market garden scale. If you happen to work with corn, is interseeding into corn. And this could be interseeding with a piece of equipment like this, or it could just be broadcast into it. And there's been some good research to identify that the earlier you plant your cover crop into that corn, the less corn you get out of it, the lower your yields are. And the later you plant that cover crop, you get more corn yield, but you get less cover crop at the end of the year. And so there's this sweet spot that seems to be around V4 or V5, which is when the corn plant has 4 to 5 leaves, where you can kind of balance those two goals. So that when the time you take your corn off, whether that's for grain or for sweet corn or whatever it is, your cover crop is way better established going into winter compared to a fall planted cover crop. So you're kind of taking advantage of this complementary growth habit and timing. And so for just a couple of pictures of what that looks like, the picture on the right is cover crops interseeded into corn that's at dry down just before harvest. And then the picture on the left is a similar cover crop, but a different mix the following spring.
And a little advice I give on that is if you are broadcasting, which a lot of people, that's the only way you can do it. You don't have this fancy equipment to interseed. You want to look at the weather. And you want to do it in a week where there's a really good chance of rain spread through the week. Because and indeed, the one time we tried to do this, I think it was 2016 or 17 when we had severe drought here in Western North Carolina. Our attempts at this were an absolute failure. Where we could drill cover crops, we could get germination from a little bit of residual moisture. But if you're counting on broadcasting under things like this, if you don't have the ability to irrigate, then you need to count on doing it on a week when there's some rain predicted to happen maybe a couple times in the week. It doesn't need to be a lot of rain, just enough to help that radicle to get out of its seed and into the soil. And once it's in the soil, it'll take care of itself.
Mm-hmm. Yeah, and it's worth noting that if you are broadcasting seed, that the larger the seed, the harder it is to get it to work. So a little bitty clover seed takes really easily. Buckwheat, maybe somewhere in the middle. Peas, for example,
can be a challenge, yeah.
Really hard to get to work. And we'll actually have a slide and a couple of slides on a broadcasting method that takes advantage of residue. But we'll get to that momentarily.
So cover cropping is a huge piece of capturing solar energy. And we're making the point that cover cropping can happen all the time, even when you're growing your crops. But it also can be part of your plan, your weed management plan. And this is, as Mark noticed, an archival picture that I actually bought a little machine to turn from a photograph into a slide, a digital slide. This is about 20 years old. It was after hearing Elaine Ingham for the first time explain to me that, and us at the 1997 EcoFarm conference, that plants are putting 50 to 80% of what they photosynthesize under the soil, and 30 to 50% of that is being pumped out into the soil as a plant exudate. And that year, I just basically was on fire with taking advantage of that. And that's actually the inspiration for this talk. And so I did a lot of experience that year. I had an impact such that my two major bosses came to the garden at different times and said, "You've done something different. There's something different about this garden. It is different and it's better." And it was that maximizing solar collection. And one of the experiments I did, we always have a problem with keeping our squash patch weeded. And this is at a resort hotel where things have to look good, right? The main point of the garden was a display garden. So what I did was first establish buckwheat cover crop. And Mark said, was it about 2 weeks out? And frankly, it was 20 years ago. I don't remember. But it wasn't. It couldn't have been a lot more, or the squash wouldn't have been able to compete. So I first established buckwheat. I then took a flamer and flamed these strips. You can see a few of them in the picture. And then we came and we actually, you're missing something because I was on fire, remember, about plants pumping in. We put little squash seedlings out. There was actually lettuce around in those patches where you see bare mulch now. There was lettuce. So we first grew lettuce even around the squash. But meanwhile, the buckwheat was growing up. Then we harvested the lettuce, and because we didn't want weeds couldn't happen, we did mulch a little bit in those areas that we still had flamed bare soil in. We didn't think that it was worth trying to grow anything else because we knew that shortly the squash was going to take over. Then Robin Kahanowicz, who is a longtime active member of CFSA, was working there and was part-time working in the garden. And she came down every week, twice a week, with hedge trimmers and just cut enough of the cover crop back to allow the squash to grow into the cover crop. And basically, once the squash grew in, it rapidly canopied over the area and we didn't get weeds. And that year, that patch was the most weed-free squash patch we'd ever had. It also yielded incredibly. And we had probably, I don't know, in an area that was like about 100 feet wide, 100 feet long by maybe 60 feet wide. We had maybe 10 or 15 lamb's quarters and amaranths and weeds like that managed to find their way up. Otherwise, we had complete control. And wherever we didn't need to cut it back, we had flowering buckwheat that was feeding the beneficial insects. By the way, I don't think you need to do the hedge trimmers. I think there's plenty of other tools that could have done that.
Yeah, would a weed eater work?
Weed eater would work. If you had an Allis-Chalmers G-type tractor and you could drive over it early on anyways, they would eventually get too long for that. But in the beginning, you could just have a little side mower or something that mowed it. Lots of different ways to. Buckwheat's very easy to kill. This is actually a slide, and these are the peas that we had growing that you saw in the earlier slide, growing amongst the cauliflower. This is Holon Dow. It took me a long time to find these. I finally, years ago, I got a directive from my same employer at the Highland Lake Inn. He'd eaten pea shoots somewhere. He said, grow them. And so I tried lots of peas to get the pea shoot that was best. And finally, I learned from Stokes Seed Company that they had a large demand for Holon Dow in Canada for Chinese restaurants that grew their own pea seeds. By the way, if you're buying them from Stokes, be sure to order the untreated ones. As an organic grower, you don't ever want treated seed, and you sure don't want to eat pea shoots off of a pea seed, off of a treated pea seed. But I learned from Mother Earth News when I wrote an article about this on winter gardening that they looked it up and that Holon Dow is spelled differently, but phonetically Holon Dow means pea shoot. This is the Chinese variety pea for pea shoot. It makes a much more succulent, bigger, and robust pea shoot. And what I learned at Highland Lake Inn, where we could use a lot of these, is that I could plant these amongst all kinds of crops any time of year except for deep, hard freeze when they would be damaged, and they would grow. They would produce pea shoots in the summer or in warm weather within 10 days, and I can get 1 to 3 cuttings from them. All pea shoots reach a point where they're not worth it, where the growth gets uneven, and you can't easily grab a bunch of them and cut them at that sweet spot where they're tender. And they also start to get like dying material from the multiple cuts where you have too much dead stuff in there. So at a certain point, you're going to stop harvesting the pea shoots. What happens in the summertime is they don't die, but they kind of just linger there. They're planted densely enough because you want pea shoots that they suppress the weeds, and they just kind of sit there as a kind of green, kind of brown living mass. But what can happen is you can have a week, like we often have in the mountains anyways, where a hurricane blows in or 10 days, and they have all this still latent energy, and they may suddenly shoot the vines out and make you a small crop of peas. So it really can be quite beneficial to grow these, and I highly recommend any number of pea shoots work, but Holon Dow I find to be the one that I get the biggest volume and the highest quality from.
Okay, for a quick kind of a a side jaunt into a little bit about cover crop establishment, because I mentioned this a few slides back, where broadcasting cover crop seed can be a little bit dicey. Totally depends on the weather. And the surest way, or maybe the easiest way to get you close to being like sure success, is to do what we call the sow and mow method. And it doesn't have to be mowing, but that's just maybe where this whole thing started. But you broadcast your cover crop seed into a standing crop. That could be a cover crop, it could be a cash crop. And then you flail mow the whole thing down, or you weed eat, or whatever your mower is of choice. It creates this nice mulch. It just kind of lays on top. And even though it's a little, it doesn't have to be a lot of mulch. It could just be a little bit. And just a little bit of mulch can go a really, really long way. Significantly improves germination, like by a lot. I can't say enough good about this method. If you have like standing crop residue in there that you can throw your seeds into and just chop down, it's super helpful method.
Yeah, I can testify that this particular, you can see the cover crop I was sowing into in the back of that slide. It was a really high multi-species cover crop. And we couldn't fit the next slide I'd love for you to see here time-wise, but it gives me a moment to promote a talk that I have coming up that's going to be online at livingwebfarms.org. That's going to be next week on Tuesday. You're not going to get to know about that because you're not going to see it till after this. We're pre-recording this. But you can go back and look at it. And when you go back and look at it, you'll see the result of this, which is that within less than, I'd say, 8 days, we had cover crop coming up that was 6 inches tall because we had good rains and all that biomass held the rain in, and the cover crop just jumped incredibly. The one time this system doesn't work is the same situation I talked about. It was 2016 or 17, severe drought. We couldn't get the cover crop to germinate for anything. And we actually had sprinklers, but with that much drought, even with the mulch covering, it wouldn't work. So it's not a guaranteed situation. Drought's the wild card.
Mm-hmm.
Drought's a wild card about a lot of things. So.
Yep. Final note about this slide is that the picture on the right is a zoom in of a similar situation. It's not this same situation where Pat's broadcasting, but that is a crimped cover crop. It was a crimped summer cover crop with, in this case, it's a winter lentil that was planted into that. And it came up really nicely in that crimped crop.
And by the way, one last point I'd make, you don't need to go back. I don't recommend sowing from a bucket. I'm pretty good at it. I've been doing it for a long time. But if you get yourself one Brandis Earthway, one of those, strap over your shoulder seeders, it is a lot more cost effective as far as seed goes. You can get far more even distribution and not use as much seed. It was at the other farm. I didn't want to take time to go get it. We have a couple farms.
Yeah, and so just to maybe provide an example of a similar situation, it's not exactly a sow and mow, but can be done really easily, and I think works really well, is in cutting sweet potato vines, getting them out of the way as you harvest, dig up your sweet potatoes, spread cover crop seed, and then just put the vines back. And so that's the sequence of pictures that you see there is like cutting vines, of course, digging potatoes, then we spread seed, and then the picture on the right is all the leaf mass just kind of put back on top of that. It's super easy to do. It's lightweight. It's not any heavy lifting, and it was relatively quick. And this is a picture about 10 days later and I think it was a oats, clover, and buckwheat mix planted in a little bit late for buckwheat, but middle October, and within 8 days, it looked about like this. So really good establishment with just simple as pulling the vines out of the way and putting them back.
I love this because every year I look at all those sweet potato vines and just hate that we're not using them somehow. If anybody doesn't know it, they're, by the way, edible. So make sure and harvest a bunch of them to eat. They're really good eating. But you can't possibly eat all the sweet potato vines you're going to have for any sweet potato crop. And they're also, ironically, sweet potatoes are nutritional powerhouses, but the one thing they don't have a lot of is protein. The leaves do. And so protein is also nitrogen. And we're still capturing more solar energy for our crop by pulling them back on top of that seed, because that solar energy is embodied in that buckwheat residue, and it's going to decay where the cover crop is and going to become rapidly available and taken up by the cover crop rather than being lost. So it's a win-win thing, and I love that. We're going to be doing it next year, I promise you. Yeah.
Okay, so moving on from cover crop methods, just jumping right into kind of like intercropping your cash crops together.
So a few years back, my coworker and friend John Henry Nelson sent out a video for us all to watch, and it was you, Lovell, who unfortunately recently passed. But he is a brilliant biodynamic grower, and he was talking about the fact that turmeric and ginger are dynamic accumulators. He also tells us that they're nitrogen fixers, and once again, we don't know how. But he knew that for some reason, and I hate that I didn't get from him the details, more details about that before he died. We never count on people dying, unfortunately. Or fortunately, maybe, I don't know. Anyway, when he said that, I thought about the fact that both turmeric and ginger are edge plants. They don't really like intense heat. And we have tomatoes which need to have space between each other. And I thought, what if we put tomatoes and ginger in between? We basically give 2 feet to every tomato we plant. And that's about the only way we can be assured of not getting various tomato diseases. I thought, what if we put turmeric and ginger in between them? I ran it by you, Lovell. He said, great idea. We've been doing it for a few years. And we haven't done a test to see if we're losing yield on the tomatoes. I suspect we're losing somewhat. Ironically, that tape you see in this picture is for another trial that was being done on those tomatoes. And I just didn't think to say, while you're at it, notice, please, if the last 10 or 15 feet of that row, which we didn't have enough turmeric plants for, is giving a better yield. I don't think it's giving much of a better yield. The plants are all about the same size, and we're getting, excellent yield of a great variety, Czech bush tomato, which is a bush that produces all year long. So it's kind of like an indeterminate bush. And we're getting huge turmeric. They're benefiting from it incredibly. And we've seen that the turmeric and ginger actually seems to do better interplanted with the nightshades. And something that we just figured out is this is in greenhouses. In greenhouses with a little bit of mulch, the turmeric and ginger will not die and freeze out. It'll come back the next year. And so we actually have right now a greenhouse planted to loads of turmeric plants that we just never got in the ground. And they are going to be growing next year, and we're going to plant tomatoes in between them. And that's where some management might come in, actually, because if the turmeric gets anything like the turmeric in here, we're going to be actually making that turmeric work harder and taking some leaves off it. And that's real important. It's a point that we want to make over and over again. We're in charge. The main crop that we're going to be aiming for next year is going to be the tomatoes. So the turmeric is going to have to wait, but you know what? It will. And it'll come on strong when the tomatoes are done. The turmeric is not going to really die back until sometime in late November, early December, since it's in a greenhouse. And we will, by next November or December, get an incredible crop of turmeric, where actually what we're growing were tomatoes. And right now, the turmeric is slowing down in a nice crop of kale. So we're getting lots of use from that greenhouse.
Yeah. And maybe it's worth noting, I think we talked about this earlier, that ginger might be a preferable over turmeric because of
it actually is.
The leaves are a little bit smaller. So well, maybe they let light through a little bit better.
What I'd say is it's preferable for the tomato, but we actually think we see more response as far as the crop benefiting with the turmeric.
Gotcha.
The ginger maybe it's not as robust, and it doesn't get take as much advantage of the situation. But it works for both, But yeah, if you want to try this first and you're a little nervous, start with ginger. It's got more airflow, and it works. It probably will be easier on your tomatoes. But I can tell you, those tomatoes aren't hurting at all. They're producing really well.
Gotcha. And so, for some other examples, before kind of launching into some examples, I think it's worth maybe putting a little bit of a framework on this. And I think that this could work well if you can just do a good job of pairing overstory and understory plants. An overstory being something like corn or okra, grows tall, might have spaced out leaves, thinner leaves to allow enough light through to get to the understory. Or maybe there's just a good cool season, warm season thing going on to where the cool season stuff is okay to hang out as an understory plant until the corn or okra or whatever your overstory plant is kind of starts to die back. So I think while I personally haven't done this with okra, at least not on purpose, had some volunteer cowpeas that worked okay in okra. I think okra could work if paired with something like the cowpea, something that's like a pretty vigorous understory plant, vining one. And granted, that's like those share the same season. It's possible that you need to be pretty particular about your varieties. I was growing that in Puerto Rican evergreen, which is one of the ones that's been recommended. And while you're going through and picking okra, it might be necessary to thin out the leaves, thin out that overstory a little bit, which are food, by the way. You can eat okra leaves for sure, along with the pods as you're harvesting them as you go along, freeing up a little bit of space and sunlight for everything that's underneath. Now, in the understory, it could be a lot of different things. I'm sure everybody's familiar with the Three Sisters, where you're pairing squash with corn and with beans, but it can be way more than just squash and beans. For example, sweet potato also sharing that same warm season, but it could totally be cooler season crops like onion, pea, beets, etc. And so the picture in the top right is onions and oddly gladiolus, but in this study, they were also testing out peas and beets paired with corn. So taking advantage of the different seasons there. Cool season crop hangs out in the understory until it's sort of released once the corn starts to thin out or is harvested.
And a couple of points to elaborate on what Mark is saying. One is that you might have cowpeas on the south-facing side of your okra if you're growing it east-west. And you might have lettuce on the north-facing side, and that might allow you to have lettuce get enough cool conditions where it does well in the heat of the summer. Another is that you actually not only can eat the okra leaves, but cowpea leaves are actually very good eating too. Mm-hmm. So you will be eating, greens while you're doing this. And then finally, I just like to reflect on the fact that we always talk about the Three Sisters, but I guarantee you, I'm certain that the indigenous peoples that employed this were doing the Three Sisters, the nuclear family, and the extended family, epazote, cilantro, a whole array of edible greens, things like galansoga. All of those things were being harvested from that same patch. That is the way indigenous farmers farm. There's not an opportunity that's missed. There's way more nutrition on the average square cornfield than we even consider. It's all capturing solar energy, and it all can nourish us or nourish the soil.
Mm-hmm. And as maybe a final note on the kind of like framework for all this, I think it's fair to expect a lower crop yield per crop, so that like your corn might not do as well as if it were like all on its own, or your squash or your sweet potatoes or whatever is sharing the space. But it's I would expect, however, that instead of a lower per crop yield, you would at the same time see a higher per area yield, so that like your combined corn and sweet potato harvest is more than if you had grown those things in separate spaces, which is fun and fascinating in my opinion. And not only from a yield perspective, but probably also greater biological activity, like we've been talking about this whole time, and potential future fertility, all that kind of good stuff plugged in from just having those things share the same space.
And I would say to that you should probably count on a reduced yield, but you may be pleasantly surprised. One example I just gave was that purslane in that year of drought. But also, we did this, and we're going to have a slide showing it shortly. We planted multi-species cover crops into our brassicas, right into the mulch bed, and they did really well. They were like really lush. If the kale and the collards weren't good and tall, they would have been competed with by the cover crop. And literally, in early May, when normally we would have taken our kale out because of how bad it would have looked, my coworker Jeremy Greist walked out with a huge armful of kale he just harvested. Pat, I swear that kale's doing better. And I would attribute that to the fact that that cover crop was keeping the soil cool. And it was respiring, and that's cooling the air. And so actually the crops did better. And another thought that I just realized while we're giving this presentation, because the possibilities are endless, is there are times the crops we have actually benefit from the protection that a cover crop provides. Benefit less frost damage. You can have fava beans do better in a mixed planting than you'll have them do on their own. And so I think because we have to budget and make sure that we're going to do well as farmers, we should always count on a somewhat reduced yield, but we may be very pleasantly surprised. It may actually be a maximized yield.
Absolutely. Okay, final example.
Okay, this is the same time that I talked about where I just went kind of wild with interplantings at the Highland Lake Inn. And indeed, there's one I don't have a slide of where my ultimate boss, the matriarch of the Lindsay family that owned the Highland Lake Inn, walked out and looked at it. She said, "That's almost too much for me. I almost can't stand to look at how much you have planted in there." I had so many different varieties of things that were going to come out. I had cilantro, I had green onions, I had lettuce, I had all these different things mixed in to a main crop of, I don't even remember what the main crop was now. I think it was probably broccoli or something, right? But the broccoli were young seedlings. But this was another example. This was, essentially we planted small seedlings of fennel. And as they were established enough where they wouldn't be too encroached on by lettuce, we came back and seeded lettuce. And you can see that they're both thriving here. The lettuce is gorgeous and it's due to be harvested. And that's probably good because it's going to start to impact the fennel a little bit, but maybe not even all that much because most of the leaves of the fennel are up above. And the old way we looked at it was, but they're competing below. That lettuce is taking nitrogen and taking nutrients and water from the fennel. Well, the fennel sure doesn't look like it. And from what we know now, probably not. They're both pumping exudates into the soil and maximizing the life of the soil food web. So that's basically the story there.
Mm-hmm. Yeah, I think if we put in, that's kind of the end of the kind of intercropping idea before we move on to weeds. But of course, there are going to be many, many other combinations and sequences of crops that you can do. And we can't go over them all, of course. And maybe the best guiding principle here is that idea of complementarity, just things that have complementary growth habits, architecture, timing, etc. Find ways to combine those so that you've got just a multitude of species in a relay or in the same place at the same time.
Two other easy ones that I can think of that could have gone in there would be pea shoots or radishes. Both of those would have easily worked in the same situation. Okay, this is actually one of the things I'm kind of on fire about. I've been an evangelist for weeds for a long time. Long time ago, Mother Earth News wanted to buy an article I wrote on weed control. And I had to hold my ground and say, no, you cannot remove the first paragraph, because my first paragraph was an ode to weeds, making the point that they can be edible, that they can have flowers that are beneficial, making the point that they are covering the ground when we're too busy, are distracted to go ahead and get something out there and cover the ground. They let me leave it in, and I think the article is better for it. But what I've learned over the years, and I think I already mentioned, is that a lot of the weeds are not only edible, but oftentimes way more nutritious than what we're growing. And so here we have two weeds. The one on the left is Galansoga. I don't know if you can see it very well. We don't have the ability to blow it up. You might be able to. A lot of people don't know it. But in the very lower left corner, there's a nice version of Galansoga. It took me 15 years to eat this because it's kind of hairy looking. Didn't look very edible to me. But now I eat it every day, all summer long. And I just count on the fact that it's a wonderful self-seeder. So I have endless successions crops of young Galansoga. And by the way, that's all you want to harvest. It very quickly becomes very leggy and stemmy, and it's not worth the trouble. But it's such a self-seeder that it regularly gives you young crops of it. And if you think of it, instead of it being a horrible, it's got all kinds of uncomplimentary names. I remember Tresca Lindsay at the Highland Lake telling me that the French call it German weed and the German call it French weed. It's not a popular weed. It's called no business weed in the mountains, among other things, or summer devil. But it's actually was a major food crop for all the southern hemisphere of the Americas when the indigenous people were not conquered yet. And off the charts nutrition-wise. It is way more nutritious than the kale that is in that picture too. And I actually loved that there was a bumper crop of it this late in the season. On the right, you have what is also maligned by its name, known in the mountains as pigweed or red root. It's wild amaranth, and it also was a major food crop for the American Indians. If you're in the Caribbean and you don't have callaloo at your market, which is another name for it, you're going to be very reviled by your customers. It's a staple green in the Caribbean. There's a classic fish stew they make with it. It is, as you can see, it looks like we planted it there. It's incredibly rapid grower and incredibly productive. And if you let it go, it will cover up your crops. But you don't have to let it go. You can just come in and harvest it. And indeed, when I was in Jamaica, um, the man I was working with was talking about the difficulty they had in being able to afford cover crop seed and the need they had for cover crops to help to blunt the impacts of the climate change induced increased winds. And the winds there are so strong that he showed me his winter squash, and it was a young plant, and the vines were just being whipped around and battered. And he said if I had cover crop growing, those tendrils could grab onto that and protect it. And I just looked at him and said, well, you can't afford cover crop seed, but you know how much seed each amaranth makes? Something like 250,000 seeds to the average amaranth plant. You can gather that seed and grow callaloo and use it as a cover crop and as a crop to harvest. And so I want to encourage people to next year eat these weeds, see how wonderful they are. My wife and I actually don't even want to look at brassicas in the summertime. We prefer these weeds and we eat them all summer long. And yet they can be cover crops. And while they're being cover crops, they're suppressing other weeds. You let these go to seed, you're going to have lots more next year. One final point about the amaranth. When it's first coming up, the under leaves are a brilliant, not about brilliant, they're a deep purple. And at that stage, they work fine in salad mix. So you can use them as a salad mix also.
Yeah, definitely be careful about letting them set seed, but before they're setting seeds, they're delicious and cover the ground, keep weeds back, other weeds back, I should say.
But I would say as a gardener, if I didn't have Galansoga, I would introduce it. That's how extreme I've gotten. And I celebrate every new, I don't try and stop the seed. I celebrate every new iteration of it because it's my next crop. And I'm eating it all. But the point is you have to eat it or it's a problem. If you eat it, it's not a problem.
Yeah.
And here's two others. And I'll start with the one on the right because that's chickweed. You may all know it. And I will readily admit that, once again, probably about 25 years ago, my wife, who loves chickweed, got on my case and made me leave it in a lot of my garden beds in the fall. And she never did that again because it took over, What I've also noticed about chickweed, if you're pulling it, the soil is really good underneath. I mean, there's some power to its exudates. Susan Weed writes about all the different medicinal qualities to it. It's incredibly good for us. And then on the left is what we've already mentioned, which is the purslane. And purslane is a natural, actually this summer, talking about the cost of seed, Ian, one of our team members, went out and collected several ounces very quickly of purslane seed that we'll be sowing underneath. So that's one you can easily gather for yourselves. And then we just ordered for next year one that grows taller. It grows about 8 inches tall. That'll be easier to harvest. The other thing I've just learned, which I didn't know or hadn't noticed, if you keep harvesting it, you can extend the season by a lot. I consider it not really sellable once it has started to set seed because those seed pods are really kind of tough and not fun to eat. Too much work to work around. But if you do multiple cuttings, you'll delay that setting of seed. Eventually, every plant is going to say, the heck with this, I'm setting seed. You have to be done. But you can get a lot more out of it, too.
Mm-hmm. Yeah, purslane is one of my favorites. I think if you keep up with the harvest, keep the seeds at bay, that's a really nice one to work with.
And it's the highest of the able to be eaten raw. Flaxseed is higher, but it's the highest plant source of omega-3 fatty acids, so it's really good for you, too.
Okay, so party thoughts. Just remember, you're in charge. You can cut back, you can harvest that secondary crop as needed. Be willing to do that. Be willing to cut back or harvest or whatever it is if that secondary crop is getting too competitive with the main crop.
Like I said, we'll probably be pulling some leaves off of that turmeric so that it's not crowding the tomatoes because it's going to have a huge advantage. It's in there now.
Yep.
Yeah.
Yep.
And then timing. Sometimes you plant, you're like with that buckwheat, I sowed it out before I then came through in flame so that it was well established and could suppress the weeds before the squash grew into it. But with another crop like that lettuce, I wait till the fennel is at a good size before I undersow it. Or like you might undersow your tomatoes, maybe just a few weeks before they reach the point of the light coming in because they're starting to drop leaves. So you have to basically keep observing. That's the number one skill that every farmer and gardener needs. Observe those rhythms and learn to work with them.
Mm-hmm. Yeah, and just be patient, so it takes time. It takes experimentation. Even if you do develop like a lot of knowledge about how to do this, or you think you're a skillful manager, every year ends up being different anyway. Some weeds have their years, and you might have to just work around those, or you might be kind of like sitting pretty because you have a weedy year that's a weed that you want.
Oh, and a point you made to me before we did this, but we didn't mention is we're not talking about perennial weeds. We're not advocating a friendly relationship with perennial weeds.
Yeah.
Perennial weeds, a different story. Some of them may have advantages, like mugwort has multiple advantages, but I would never let mugwort happen in my field.
Pernicious.
Yeah, right.
Yeah, avoid that one for sure. Yeah, that's a great point. Thank you for bringing that up. Yeah, I like that. Well, thanks for joining us, everyone. If you have any questions, feel free to reach out via email, and please join us for the live Q&A.
Okay.